Welcome to the third section in your unit menu, the mole. In this section, we are going to combine what you learned in both Part 1 and Part 2 to perform two-step conversions with particles and mass. At the end of this video, you should be able to perform two-step conversions using molar mass and representative particles. Remember, a representative particle could be an atom, a molecule, or formula unit. We have already learned how to convert moles into particles and vice versa by using the conversion factor 1 mole of any substance equals 6.02 times 10 to the 23rd particles. We have also already learned how to convert moles into grams and vice versa using the conversion factor 1 mole of a substance equals the atomic mass in grams. These two conversion factors can now be combined. So for example, let's say you're reading a problem and the known gives you particles, and you have to figure out how many grams that is. What you'll have to do is go from particles to moles using the 6.02 number. Then to go from moles into grams, you'll have to use the molar mass. If you were given the opposite, for example, you were starting with grams and you had to convert to particles, you would again go from grams to moles using the molar mass and go from moles to particles by using 6.02 times 10 to the 23rd. So this is a really nice layout of the order of steps that you would take. So this might be something good to jot down in your notebook. And as always, here's an example. This question says, what is the mass of 1.79 times 10 to the 24th formula units of potassium phosphate? I like to break my problem up into the known and the unknown. So I know that I have 1.79 times 10 to the 24th formula units of that substance. And what I'm trying to solve for is mass of the substance. So I always start with the known, and I do like to put it over 1, which you absolutely can do that. And you may say, do I have to write all of these substances all of the time? Well, I think it's really up to your teacher whether or not he or she wants you to do that. I do tell my students that it's important to write the substance because eventually we're going to get into this thing called stoichiometry, which sounds kind of scary, but it's not too bad. But with stoichiometry, you're actually going to have more than one substance that you're working with, so it's important to write the substance down so you get into good habits. But you should always check with your teacher. The next step is if we have formula units on the top here, you have to think about, well, what conversion factor do I know that relates formula units? Well, you know that there are 6.02 times 10 to the 23rd formula units in a mole of a substance. So in this case, you would have 6.02 times 10 to the 23rd on the bottom, and then 1 mole of the substance on top, and you can see formula units here will divide out with the formula units there. If I solve the problem right now, I would get my answer in moles. However, I want my answer in grams. And so the last step would be to calculate the molar mass of potassium phosphate. So it should look something like that. And then what you do is have 1 mole on bottom of the substance, and then you would have the 212.27 grams, which is the molar mass you calculated, on top. And you can see moles and moles divide out. You're left with grams, which is exactly the unit that you wanted. When you calculate this, you should end up with a value of 631 grams of potassium phosphate. I hope this video helped you to understand the types of calculations that you'll be doing whenever you're converting from mass into particles or vice versa. Like I mentioned, that layout of going from grams to moles into particles or going from particles to moles to grams is really helpful. So hopefully you jotted that down in your notebook and you can use it as a reference as you complete your practice. I think you did a great job today. Thank you so much for watching.